Okay, good, nice, perfect. Okay, so we have discussed functional interfaces, and I did give you time to go through this Arraylist demo. Well, I'm calling it Arraylist demo. I better change the name of this to I will call it collections demo, because in general I have connected. Oh, sorry. So let me change the name to E will be lowercase. So collections demo, this is our, so this contains example of array list and linked list and stuff and all, right? So it contains everything and also a map. Well, so you know what, collections itself, we can spend half a day, half of a full, I mean, one full half day or one half day, 4 5 hours we can spend only and only on collections. It's but then I'm not spending this much of time because there are many other things also that we are supposed to cover. But that's again not the reason. Main reason is that they are very simple to understand. You will be able to find all on your own. For example, if I ask you to get the value of a particular element, so you can see, you just explore, say get an index. If you say get index 3, what will it do? It will give you the index, the third index, 0 1 2. It will give you 12. As simple as this. So if you explore, you will be able to very easily understand the functionality that is provided by each one of these collection, these components that are there in the collections framework. Okay. So before, how many of you have finished getting the minimum value, the main value, successfully? How many of you all could get the main value successfully? Tell me. Done. Very good. Very good. Very nice. That's nice. Very good. Very nice. Very good. Very good. Very good. Very good. So almost all of you have got it. Now you see this, the amount of code that you might have written in order to get the minimum value, and the amount of code that we have written in order to map, in the amount of code that we've written in order to filter. I repeat once again, see, filter is one thing that we have done. Then we have also worked with mapping. What do you mean by map? What map exactly means here? You have mapped list of integer into a list of string. You have changed the data type. So what you had was an integer, the list of integer. What you got after running this logic is the list of string. So you have mapped integer to string, and this is how you have done it. Like, you have concatenated the value with some with a prefix employee code, and that's what you have put into the new list, isn't it? So I'm calling it mapped values, modified values. Well, modify, change, that's not still a good term. That's bad term, bad way of saying it. Map is the way to refer to whatever we have done over here. So you are not changing the original data structure. I repeat, you are not changing the original data structure. The list of integers still remains as it is. If I print after map logic, if I print here system.out.println, if I print values, it will still give me whatever the original data in values is. Take a look. You see this here? I get this array of string, I mean a array list of string, and at the same point of time, I get the original values as well. Correct. So you don't change the existing stuff. You create a new data structure, but then the new data structure that is created that has values which are mapped values from integer to string. You have originally integer, but you have now string. Okay, don't confuse this map with the map that we created, that we used earlier, map of integer. No, 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 no. This is normal English term, mapping of values. Like, I will map one thing to the other. I map one thing to the other. That's exactly what we are doing. Now you see the amount of code that we have written over here. Well, you will still say that fine, you have written just few lines of code, no big deal. But then you see how I'm going to do exactly the same thing with fewer lines of code. And trust me, it is not about fewer lines of code. I repeat, it is not about fewer lines of code. There is a lot of other benefit as well. What is that benefit? Let me explain. So I will go to streams demo. I will again create a list of integer, same stuff, list of integer. Okay, java.detail.list, and I'll say values is equal to, and this time I will not say new array list, and I will not say values dot add, okay, integer 123, or values dot add, though I can do that, no harm, I can do that. But instead of doing this, okay, one and the same thing, so I will not remove this code, I will keep this as it is. Okay, but this time I will use a helper class for arrays. I'll say arrays dot as list. Can you see this? Arrays dot as list. So I will give some values over here, which is kind of an array of integers 12 comma 40 comma 45 comma say 75 comma 100 comma 200. So see this here. What will it do? It will convert this array of integers into a list. Arrays dot as list. So instead of writing those many lines of code, it becomes easier for me to initialize the value of arrays. Correct. So this is one of the ways that you can create a list of something. Now, I will proceed further now. And what was my requirement? See, you remember, filter out all those elements which are greater than 50. This is what we did last time, right, in the previous program. Now see what I'm going to do. See the fun here. I will say list of integer. I will say filtered values is equal to, you know what I'm going to do now? I'm going to say values dot stream. See the way I'm writing it. I'm writing it on the next line. Values dot stream. It will create a new stream object. Dot stream will create a new stream object. This was introduced in 1.8. Take a look. This was introduced in 1.8. Here it is since 1.8. So I will say dot stream. It will create a stream internally. It will create an iterator which will iterate over each one of those values. And I give the logic that when it iterates, what is it that I want my stream to do for me? I'll say dot filter. When I say dot filter out here, friends, please see what is filter taking as a parameter. Take a look at the documentation. By now, you must be pretty comfortable understanding the documentation. Okay. By now, you must be very comfortable understanding the documentation. Tell me. I once again take it here. Tell me what is the parameter it accepts. Filter accepts a parameter of what type? Tell me, friends, tell me. No, 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 no. See, Rakesh has given an answer. Please check. See the answer given by Rakesh. What he says, what is the parameter? See, filter takes a parameter for type. Here is the documentation. Come on. Public abstract stream filter. That means this function returns a stream. And you see filter. Filter is a function. What does it take as a parameter? Please take. This is the name of the variable. This is the data type of the parameter. This is the parameter. What is it? And give me the fully qualified name of the parameter type. Give me the fully qualified name of the parameter type. Please type it out. Every one of you must type out the fully qualified name of the parameter. So the name of the parameter is predicate, but then what is the name of the type? Name of the type. It is what? Come on. I'm waiting for yes, Anikendu, you're right. Java.util.function.predicate. Every one of you must write. Yes, very good, Sabash. Very good. Java.util.function.predicate. Very good. It takes an argument of type java.util.function.predicate. Now, I will take you to predicate. Here it is, java.util.function.predicate. Can you see that on my screen? Java.util.function.predicate. I hit the enter key. And this java.util.function.predicate, what is it? Please, I want answers from you all. Come on, what is it? What is it? What kind of an interface it is? Superb. It's a functional interface. It is a functional interface. What is that one single functionality in that functional interface? What is the functionality of predicate? I repeat, what is the functionality of predicate? I repeat once again, what is the functionality of predicate? Excellent, excellent. Boolean test. No. It's a functional interface, yes, but then the functionality is what? Test. That is the functionality predicate represents. Very good. Very nice. Superb. Brilliant. I'm very happy. Fantastic. Right? So it takes a predicate. Now I will just comment this for the time being, and that is a functional interface, isn't it? So I say predicate, and you know what? This predicate is of generic type. This predicate is of generic type. What is the generic type? Can you see T out here? This T is the parameter. See this interface. You know in Java 1 from Java 1.5 onwards, you can have template based class. You can have a templated class. I repeat, you can have a templated class, or you can also call it. You can have a you can have a parameterized class. So this is a parameterized interface, predicate T. That means this T that you have declared over here can be used anywhere in this class as a variable, as a parameter, as whatever. Now this T, whatever that T is, what I mean by this is generic type. I repeat, this is generic type. So I go back over here and I say predicate of type string. I repeat, or say maybe I say predicate of type integer. The generic type is integer. I create predicate is equal to, now wait a minute, friends, please see this predicate. If I say predicate of integer, and that test is also the same T, this T is of type T over here. What does this mean? If I say predicate of integer, that means test is the function which will take an argument of what data type? If I say predicate of integer, then test is a function which will take an argument of which data type? Tell me. Sabash, very good. Excellent. It will take an argument of type integer. Super. Brilliant. Integer. Correct. Now, so wait a minute now. So predicate. What is the functionality here? Test is the functionality. And I need to write the implementation for it. Can't I write something like this? New predicate and something like this. Can't I write something like this? Haven't we studied this in case of tax calculator? Come on, friends. Yes or no? So you are clear that this is also one of the ways of writing the implementation. This is one of the ways of writing the implementation of an interface. I will be the happiest person on earth if you give me one word answer here in the chat window. What is yet another third way available from Java 1.8 onwards? How is it that I can write the implementation of predicate? One word answer. As excellent. Excellent. Brilliant. I can write it as a lambda. I can write it as a lambda expression. Very good. Very good, Monisha. As lambda expression. Well, Bharti, instead of calling it lambda function, we will call it lambda expression. Okay, we will call it a lambda expression. So I will keep this as it is. And wait a minute. Can't I write something like this over here? If integer, that integer which is passed to the parameter, or let me make it value. If value is greater than 50, return true, or else return false. And you must give very meaningful names to your reference variables and the primitive, whatever primitive or reference, whatever it is, you must give very, very meaningful names. So I'll say test for test for value greater than 50. Don't you think this variable, this reference variable is, I mean the name of the variable, this is the perfect name of the variable given the logic that I want to write here? Yes or no? Isn't it? Test for value greater than 50. This is the better name of the variable. Super, right? So this is good. Now what I'm going to do is I will just go back here and I will uncomment this, and your filter can't I pass, because filter takes an argument of what type? Take a look. Filter takes an argument of type predicate. Isn't it? Filter takes an argument of type predicate, and test for value greater than 50 is a predicate. Can't I pass this as a parameter here? Yes or no? Don't worry about this error. Now no errors. Yes or no? Can I pass this as a parameter or not? See, very simple. Filter takes an argument of type predicate. So I have passed predicate as a parameter. Here you are. This is of type predicate. Make sense? Correct, friends? Make sense? Cool. Good. Very nice. Let me put the video on. Nice. So while the screen is shared, while I share the screen, you can see somewhere, my video as well, or I'm unnecessarily starting the video while sharing the screen. I don't know about Google Meet. You can see, right? Okay, thank you. Right, thanks. Thanks. Right, so you see this test for value greater than 50, it works like a charm, no problem. But don't you think, and you'll have all agreed that I can very well write this entire thing as an expression. So I will keep this as it. I will not actually, I will comment it, but I will not remove it. I will just keep it commented. I will remove this entire thing. Okay, this entire thing here, correct? And this test is the function that I need to provide the implementation of test. So what I'm going to do is, and test takes an argument of what type? Integer. Well, whatever the data type is, it will automatically understand type inference. You remember type inference, it will automatically do the inference. I just need to specify that my lambda expression, it takes a, I can, though it is redundant, I can say integer value, right? And I can very well do something like this. I'll say return, I'll say value greater than 50. Either it will return true or false. If the value is greater than 50, it will return to you true. If it is not greater than 50, it will return to you false. But we know that we don't need to. Though you give no harm, but you don't need to. And this is just superb. This is just superb, correct? See this here? This is just superb. Perfect. In fact, even if you do not give brackets, it's okay. But if there are no parameters at all, brackets are mandatory. And if there are two parameters, again, brackets are mandatory. But here in this case, since there is only one parameter, I can even omit the brackets. So value, this is the value that is passed as a parameter to the test function. Okay, that will be passed and that will be passed. Okay, tell me one thing. Am I executing the test function here, or I am providing the implementation of the test function of predicate? I am invoking or providing the implementation. What do you think? Am I executing? Yes, I am. I am providing the implementation. I am providing the implementation. Who is going to execute it? Give me the right answer and you make my day. Tell me, look at this, see where I have used this. Which function will actually execute the test function on this functional interface? Who is going to execute it? Which function will execute the test function on, see this friends, see this. I'll say test value dot, sorry, dot, I can say test, right? I can say test, and I say 40, it will return to me true or false. It will return to me what? False, because 40 is not greater than 50. But if I say 55, it will return to me true. But I'm not going to execute this. Look at this code and tell me who is going to execute it. Come on, few more answers. I mean, all of you have put filter, 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 filter. Correct. Anyone else? Anyone out there who would like to differ? Exactly, it's the filter function. Exactly, it is the filter function. Yes, you are right, Manisha. Stream dot. So it's actually the filter function of stream. You are right. You're not wrong, Manisha. It's the filter function of stream that will execute internally. Right? That's how it is. And now, just to help you to recollect, what is that filter function known as? What is that filter function known as? What is that filter function known as? What are such filter functions known as? Come on, come on. A function that takes another functional interface as a parameter is known as what? Yes, yes, yes. Not higher function, higher order function. It's known as higher order function. Very correct. See, I did. I'm giving you hints as well. And there will be a test. There will be a test. There will be a test. So see, coming back over here, can I say filter is a higher order function? Come on, yes or no? Filter is a higher order function. It takes another functional interface as a parameter. Now I'm sure you know what is a higher order function. Now for your life, you must not forget that a higher order function is the function which takes another functional interface as a parameter. Correct? So far so good. I could have written the entire implementation like this and passed it as a parameter. I could have written, I have written something like this, a lambda expression, and passed it as a parameter. Now, don't you think it will be much more elegant? The code will be all the more elegant if I write here value greater than 50. Come on, yes or no? Wouldn't this be more elegant? क्या फर्क है? What is the difference? What is the difference? There is no difference at all. Yes, inline. Yes, Ashish, you're right, inline. So instead of declaring first and then using it, this is the actual style of using it. I repeat, this is the actual style of using it. Not that this will give you any compilation error, not that this is going to perform bad or something. There is no question of performance issue. There is no question of, good or bad. It's about elegance. This is the better style of writing it. Why wouldn't you want to keep your code concise and precise and to the mark, hasn't it? Correct. So you see this, we have used filter. Actually, I would like to now complete this. Okay. So you see this, it's giving me an error. Why? Because after doing the filter, this filter also returns a stream. This filter also returns a stream. Got that? The filter also returns a stream. But I do not want a stream. What do I want? I want a list. I want what? I want a list. So what do I do here? I'll say dot, and I will write collect. So after filtering, collect the values. Collect the values using what? Using a particular collector, say collectors dot to list. That means I'm saying convert the values you collect as a function which takes a collector, and the collector that is returned back by toList function will do a special job of collecting the values into a list, and I have filtered values. Now take a look at this, my dear friends. I say filtered values, you see, and now when I run this, see 75, 100 and 200, all of these are the values which are greater than 50, isn't it? Now, what is the big benefit here, my dear friend? See, the logic of filtering still remains the same, but you can change the implementation. No, 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 no. I want less than, 50, or say less than, instead of greater than 50, you say less than 50. Everything, your entire recipe remains the same, but you say this. Correct? It's like you have the recipe for you know, you have a recipe for chicken masala. You've got a fantastic chicken gravy, but you say, hey, oh my God, I don't want chicken. I want paneer. I'm a vegetarian. So I say, wow, no problems. What I'm going to do, recipe is still the same. Just remove chicken. Instead of putting chicken, I'm going to put what? Paneer. So the recipe remains the same. So your logic remains exactly the same, right? It's just that the implementation in between changes, isn't it? I could have created a function called, you see this now, public void, and I'll say, or rather I'll say public list of integer, okay, filter my values, and it takes what? It takes a predicate as a parameter, predicate of integer as a parameter. Take a look, see this, and I copy paste this over here. Take a look. And what am I going to do? Instead of saying filter here like this and giving the lambda expression, I will say predicate. Okay. And what is it that I'm going to do? I'm going to return back the value. So, okay. I will have to, of course, pass list of integer as well. Integer, and I'll say values, comma, correct. And what is it that I'm going to return back? I'm going to return back filtered values. Now see the fun here. See the fun here. I can make a call over here to filter my, okay, this is not static. I will have to make it static because I want to invoke it from a static. So I'll say filter my values, and I pass as a parameter to this function. I pass parameter to this function. What do I pass as parameter? I'll say value greater than, I mean value that will be passed as a parameter. Value should be greater than 50. It gives me all the values that are greater than 50. Filter my values. What am I missing? Filter my values. Okay. Yes, where am I going wrong? List values, sir. List values. Sorry. So I'll say values. Thank you. Thank you for that. Okay. So here you go. So the first parameter is list. No, actually, I was testing you all, whether you all are attentive or not. Okay. Oh, just kidding, just kidding. Yeah, I missed that. I missed that. Okay, so I'm passing the first parameter is the list of values, and the second parameter is what? The expression. And now I can get exactly the same results. But then what is the fun here? See, I'm getting this. What is the fun here? I can change in one single place. I change. So this logic, do you think this function is going to change? No. This function remains as it is. You see, I'm getting 12, 40, 45 now, isn't it? Or if I say less than, say, for example, less than, say, 15, then in that case, I get just one value, and that is 12, right? So you see, I can reuse the recipe. I can reuse the recipe by passing different lambda expressions. How easy this becomes for me to do unit testing. We will talk a lot about unit testing later, but how simple and how easy it becomes for me, to test my code, to modify my code. My application is now resilient to changes, isn't it? This is exactly so. I have discussed a lot and I have shared a lot, especially with respect to streams. I got started with streams and stuff. This is the streams demo class that I created. Look at it very, very nicely. I'm going to push my code. You take the pull and learn this and go through this very, very nicely. There will be questions on this in the test. So please go through this very, very nicely. Okay. So uh, and gather the questions. If you have any questions, then you let me know what those questions are. Okay, and then we will proceed further to the next step. Okay, this is what we are going to do. So let me push this code. Getting started with streams. Okay, it's done. Okay, so please get started. Sir, how do I rename a class? Okay, click right mouse button on the class. You will find an option called refactor, and within refactor, you will find an option called rename. Click on rename and then give a different name to it. Okay, once again, I repeat, click right mouse button on the class from the project on the left hand side, right from the tree view. Select the class, click right mouse button, say refactor, and then rename. Okay, that's how you can do it. All right, friends, come on, let's continue. So I hope you'll have all gone through the code. And one important point. Any questions? Do you all have any questions? Any questions? Absolutely feel free to ask questions. Am I audible to you all? Can you see my screen? Please confirm. Okay, that's nice. Good. Very nice. So yes, tell me now. Any questions? Do you all have any questions? And I hope you'll have all gone through, sir. What exactly does stream function do? Yeah, so stream function creates an iterator. I repeat, stream function creates an iterator internally, and that iterator iterates through each one of the elements that are there in the list. Say, for example, there are 100 elements. It will iterate through each one of those 100 elements, and it will apply filter function on each one of those elements. That's a good question. See, dot stream will create an iterator internally, and it will invoke filter function on each one of those elements that it would iterate through. So if there are 100 elements, it will iterate through it 100 times. If there are 1,000 elements, then each one of those elements it will iterate through, and filter will be applied to each one of those elements. Right? That's what a stream does, isn't it? Okay, so I hope that answers the question, Rakesh. Stream iterates through each one of those elements and invokes those higher order functions as we specified, right? Good. Now we did filter my values, right? Now what I want is, like the way we have written this function, which returns to me list of string, I want you to write a function for me, map my values. Okay, and I will not do anything out here. You are supposed to, so I'll say return null for the time being. You are supposed to, of course, remove this return null and return the list of string. Okay, and you know what my requirement is. My requirement is that you must map the list of integer to list of string with each value in the list of string concatenated with employee code colon whatever the code is. Now when I say code, whatever the value in the integer list is, we have done this, right? We have done this in this not here, not here. In the collections demo, we have done this, right? This is exactly what I want, map. So this is what I want. Okay, now I won't help you at all with anything else. You are supposed to write the code. You see the code that we have written over here. We have used a filter here. You need to figure out what is it that you will be using. You need to figure out what you will pass as a parameter to map. You need to explore. Filter took a parameter of type predicate. Whatever you will use, you've got to see what type of parameter that function, that higher order function takes. Which is the higher order function here, friends? The higher order function is filter. Higher order function is filter, right? So similarly here also, when you take stream, you will use some of the higher order function. Higher order function. You need to figure out what kind of higher order function you will be using. It's very simple to find out. Is fill in the blank, and then okay, you will use that. You will use same collect collectors dot list, everything will remain the same, but then you have passed a predicate as a parameter. That higher order function that you will be using here, you need to figure out what you will be passing as a parameter. How did I teach this to you all? Did I start immediately and did I give anything over here? No, I thought you all, you see, you put a predicate. Then I did explain to you, see, this predicate is actually a functional interface. I explained, see, this is the function. See this T and T here, you can see this here, right? T and T. This is how I explained it to you. So this is how you will explore, right, the higher order function that you will use in order to map, once again, in order to map. Come on, friends, get started. Okay, get started. How the statement is working workflow. System.out or println filter my values. Oh, Gaurav, that's really very simple. If I break it down, it will be all the more easier for you to understand. See this. Okay, these things are pretty simple. So you see, you have you have values. You already have values here. That is clear, right? You have values, which is a list of integer, right? So you have values, and then suppose I create a predicate of integer, right? And I say test for, or I'll say filter predicate is equal to, this is the lambda expression that represents this. Okay, then I will write list of string, sorry, list of integer, and I'll say filtered values is equal to, I will write filter my values. I will pass values as parameter and filter predicate as a parameter, system.out.println, and I will write here filtered values. Now this is okay, right, Gaurav? This is okay. I have broken this down into multiple lines of code, right? Uh, I will put this. What's the error? Okay, I don't need this. Right, I'm pushing the code so you can, continue from here onwards. Mapping the values using streams. Right. So you have this empty method, you need to fill this up. Come on, that's what your job is. Right? Good. Take the poll, friends. You can very well take the poll now. Okay. So see, I did give you all the hint that we want to map. We want to map. And I said 3 times, we want to map. Now, how will I do this? You see? So, I'm so sorry. I'm so sorry. This is not supposed to be a predicate. So you could have figured it out. So even if I keep it as a predicate, of course, it's not going to work. So here, because if I had told you what is it that you must pass as a parameter, I mean, it was like, answering the question itself. So, if I want to map the values, if I want to change, I already have integer, list of integer, but what I need to return back is list of string. So I will say values, once again, same thing, dot stream, correct, again. And when I say values dot stream, so let me put over here list of string. I'll write mapped list is equal to, and then when I say stream dot, I will not use filter. I don't want filter. I want to use a map. What I want to use is a map. And then when I say map, what does map take as a parameter? I hope I'm audible to all of you. All with me, friends? Okay, good. So please see, I'm going to use a map because I want to map the values. And what is it that map is taking as a parameter? Please see. Map is taking, what is it taking as a parameter? Filter was taking predicate as a parameter. This is taking function. So that was java.util.function.predicate. This is java.util.function.function. You got that? Java.util.function.function. Now when I click on this, it takes me to, or rather, I can very well go here, function. Okay. So you see here, I say project files. I can say all places. If I say all places, I'll get everything. So I'll say function java.util.function. Please see what is the name of the function here. Apply. Well, I don't need to worry because as in case of our filter also, I did not execute the test method. Test was executed by filter on the predicate. I repeat, test function was executed by filter on the predicate object. Correct? But here, so similarly here, I've got a function. Why? Because why am I interested in function? Because this map takes an argument of type function. So you see, what is a function? Java.util.function. It is a functional interface. What is that abstract function here? Now see this. This is the generic type which takes two generic types, T and R. T is the input, R is the return value. T is the input and R is the return value. So and which is the higher order function here? Take a look and tell me. Here, if I say filter is the higher order function, tell me what is the higher order function? Which function is the higher order function here? Don't you think map is a higher order function here? Is it? Isn't it? Which is taking what as a parameter? A function, java.util.function.function. And that java.util.function.function, it takes one input and returns a value back. Isn't it? It takes one input and returns a value back. So what is the input that we have over here? X is the input. When I say X, it can be anything like X, and then I want to convert it back. So I will say employee code plus, and I'll say value. Sorry, X. Correct. This is what I'm going to do, and then dot collectors dot toList. This is what I'm going to do. See this. But then this lambda expression over here, instead of hard coding it and passing it over here, instead of predicate, I will say I have a function which takes an integer. All right, I have a function which takes an integer but will return back a string. Now take a look. I go to that function, see T and R. What is T? Integer. What is R? The string. That means I need to give a function here, a mapping function, a map function. I need to give a function here which will take an integer and return back a string. So you see this, I will just simply say map function. That's it, it's done. So here instead of predicate, what is it? It's map function. Okay, this is just the documentation, don't worry about it. You got that? How will I make use of it? See, from here, you see, these are the 3 lines of code for filtering. This is for filtering. Now the following lines of code for mapping. All right, so I'll just copy paste this here instead of predicate. Okay, why do I want to copy paste? I'll say function of integer. I mean, you're going to pass as a parameter an integer and it will return back a string. So I'll say map function is equal to x, and I'll say employee code colon, okay, and I'll say plus, and I'll say x. So what would this be? Employee code, whatever is the value that is passed as a parameter, and then you concatenate it. So this map function is passed as a parameter to what? I'll say map my values. What is it that I'm going to pass as parameter? 2 things: values, the list itself, the list of integer, and this map function is what I'm going to pass as parameter. And what do I end up getting here? List of string. I'll say mapped values is equal to, and now as out, I'll say mapped values. Here you go. You got this, friends? Mapped values. Correct. So instead of using a filter, I'm using a mapped value. So see this. You see here, map function. If I now run this code, see for yourself, it will get mapped. Oh, I'm getting a null. Why? Because I have returned a null from here. I should have returned what? Mapped list, isn't it? These are those normal, kind of coding errors that one would encounter. Okay, so you see map 12, 40, employee code 45 and 75 and so on. Here you go. You're getting this, friends? Pretty simple stuff. Instead of filter, I'm using a map. And don't get disheartened at all. If you have understood only 50% of it, you are a king. Don't worry. Even if you have understood just 50% of it, you're good. All of these things will be like next to breathing. And the very first day when Java 1.8 was released and when I started working on Java 1.8, all of these things, it took some time for me also to assimilate, to understand, to comprehend. It took some time. And then, as I started using it in my project, it was like next to breathing. So don't worry about it. Just make sure that what I am explaining is what you have understood, and you have understood that well. And then you remember, you also had, you know, I also asked you to get me the minimum value. Now I'm not going to create a function and then pass it as a parameter. I'll keep it simple here. Suppose if I want to get the min value. So I will say, now listen to this very carefully and take a look at this, friends. What am I going to do? I'll say values again. And then I'll say dot stream. And I'll say dot int, map to int. Okay, map to int. Why am I going to do map to int? So that I get the min value like this. I'm converting integer to int and then getting the min value. Map to int. Okay, x2, or else otherwise I will have to give a, okay, so I will say map to int and I'll return back, and whatever is the integer, if I say int value, I'll get the int, and I'll say dot min. See, this gives me the minimum value. I'll say int min value is equal to, see how simple this becomes. And you know what? I will have to use optional. Optional. Now this is a new thing, friends. Optional of integer and int value like this. Yeah. Sorry, it will be an optional. I don't need to give this. It will be an optional int like this. Optional int. Now, what is an optional? Optional again was introduced from, since 1.8 onwards, it's there. This, it's quite possible that stream is empty. So what will be the value? What will be the main value? Will it be null? Or will it be, empty, or what? So they have a special structure created now called optional. It can be optional int, optional double, optional. So what you do here is you say, if min value dot is present, that means there is a value present over there. Optional means either there is a value or there is no value in that object. I repeat, either there is a value or no value at all. So if it is present, then I'll say as out min value dot get as int. This will give me the int value, the minimum value. Okay, let me make it easier for you. Okay, I'll keep this code. I will keep this code. This is also perfect, but I will give you much simpler code. Okay, but if it is an integer, I will have to use either a map to int, or else I will have to use a comparator in order to get the minimum value. In both the cases, it is beyond the scope. I mean, I don't want you to, I see, we can, I can do this training for 20-25 days, right? We can go on and on and on and on, correct? As I said, I, I've been working on Java since almost now 20 years, and I'm still learning. I'm still learning each day. So we can go on and on and on. But I don't want to pick up topics which you feel would be difficult, or if we as a team, see that, okay, if getting into this would be at this stage, since you have not, put yourself into the real life project, it will be a bit of a challenge for you to pick up those things. So unnecessarily wasting time. Instead, we will move on to the other topics. So I just want to keep it simple, right? So I am keeping this as it is. Don't worry, even if you've understood a part of it, it's absolutely fine. In short, what I'm trying to convey to you is the power of streams. That's what I'm trying to convey to you. See, 12 is the minimum value. You can see that. If I say max, it will give me the max value. See this. Now when I run this, see how simple this becomes. 200 is the max. So see the amount of code that you are writing, see the logic that you are writing. It is so very simple and so very easy to understand, isn't it? So streams are very powerful. What I have explained to you about streams is just a drop in an ocean. There are many things. You can have parallel streams. You can do, you can find any match. You can have all match. You can have none match. You can find an element in a stream. I mean, there are so many things that you can do, but I think this was a good primer. But one last thing, one more interesting thing I do want to share this with you. I have used filter, and then in another example I used a map, isn't it? You see, I have used a filter here and I have used a map here. Isn't it possible that I may have a need to get the employee code string, employee code, mapped value, employee code colon, of only those employees where the code is less than 50? Don't you think? I may want to filter as well as map. Possible or not? Come on. I may want to, I may want to do a filter as well as a map. Possible or not? Come on, come on, come on. Yes. So is that the case that I can do either only filter or map? No, not at all. So see what I'm going to write here now. I'll say values dot, I'll say stream. Okay. So here let me say list of string. I'll say mapped and filtered values. See, filtered values is equal to values dot stream dot values dot stream dot. I will say yeah, I can do a map first, or I can do a filter first, and then I'll say x greater than 50 or maybe less than 50 dot, I'll say map. Okay, and here in the map I'll say x and I'll say x dot, or sorry, I'll say employee code, and I'll say x. Now I've got the habit of using x and y, but then you can use whatever, whatever variable you want, you can use that here. And I'll say dot collect, collectors dot to list, done. See, now I'll say s out. Okay, and I'll say mapped and filtered values, just to separate it on the console. Here you go. Oh, there is an error. Mapped and filter values. Why? Okay, here you go. Isn't it? You see this? Employee code only 12, 40, and 45 because less than 50. If I make this as less than, say, 15 instead of 50, I'll get only one employee code, that is 12. See? Only employee code 12. So I am mapping it, filtering it, as well as mapping it. My dear friends, I'll certainly share my LinkedIn profile and stuff with you all. You'll get connected and send me a message the day you in your real life project really feel that writing all of this, using streams, filter, map, collect, collectors, this, that becomes, it's like cakewalk, and it's like next to breathing for you. Do send me a message on LinkedIn saying that, okay, today it's like next to breathing for me, and I'll be really very happy to know that. And that day will certainly come, certainly come. Okay, so for now, I want you to explore the code that I have written, and especially see more on streams, especially see the map thing that I have written, and then filter plus map and stuff. Take a look, run the code, maybe make some changes here, make some changes instead of employee code, say employee ID, something like that. Make changes and see how it works. Right, I have made it employee ID instead of employee code. Okay, friends, take the pull. Come on, take the pull. I'll give you all 15 minutes to work on this, and then we will get started with. So we close our streams thing over here, and then we will get started with this time. Oh, it's 4:05. We have time. So you complete this in 15 minutes, and then we will move on to, exception handling, right? We will move on to exception handling, and then, good. Okay, we will move on to some other topics as well. Right, so hopefully you can see my screen now. So you see, we are supposed to start with exception handling. Now, what do you mean by exception handling in the very first place? So when I had started my career, and when we used to write applications, let me give you an example. Account is a class, for example. And if I have a function here called public void, and if I say withdraw money, okay, withdraw, and I need to pass a parameter, I say float amount that needs to be withdrawn, and then and the account there is something called balance, private. I'll say float balance, some balance that is picked up from the database and initialized. And then the moment you say withdraw, you have to do what? You've got to reduce it from the balance. So balance is equal to balance minus amount. That's what you need to do in that withdraw method. But do you think you're going to do this directly, or you will first check? If you're going to check balance is greater than equal to amount, then in that case, only in that case, you do this. Or else you've got to tell the client class. Now, what do you mean by the client class out here? Okay. So what do you really mean by client class out here? Client class is the class that uses this class. So I'll say account, sorry, Java class, and I will say account app. Right, so this is the client class. Client class means what? This is the client of the account class. This invokes a method on the account class. So here I will say account is equal to new account. Okay, and maybe I want to initialize the balance. Whenever I have an account object to be created, I will not have a default constructor now. I will have a constructor which takes one parameter, and that parameter would be float initial balance, and then I'll write this dot balance, sorry, this dot balance is equal to initial balance. Okay, that's how it is. So I go back here and I can create, now I cannot create an account without a parameter because there is no default constructor now, correct? So I'll say, the balance to start with is 5,000. That's what the balance is. So this is good. But now I say account dot, I say withdraw. I say 5,001. This is what I'm doing. And there is a logic out here that if the balance is greater than equal to amount, only then go ahead, or else what? Else what? I need to notify notify is just the term that I'm using, not the dynamic notification or something, but this account app, this client class must know that on invoking withdraw, whether the withdraw was successful or it failed. When I had started my career, there was nothing like exception handling provided by the programming platform like Fox Pro 2.6 or the earlier versions of Power Builder. Later versions of Power Builder did provide exception handling, but the earlier versions of Power Builder also did not have exception handling inherently built into the platform. So what we used to do, but then the requirement is there. The client class must know so that it can take the, it can do something accordingly. So what we used to do, always, we used to return an int from such functions. We used to return an int, and we used to return 0, something like this. That means success. We used to return a, else return -1. So this used to indicate a failure. So when I go back over here, I will always check if withdrawing of money is equal to 0, it was success, right? System.out.println, I'll say success, or else I will say system.out.println failed. What do you think will be printed here in this case? What do you think will be printed? Success or failure? It's going to fail. Why? Because I'm trying to withdraw 5,001. Isn't it? It failed. This is how we used to handle it. But this is no elegant way of handling it. Why? The reason is that what if I really wanted to return back not the return code, not the success or the failure code, but I wanted to return back some real value. For example, I wanted to return back the current balance. This is what I want. I want to return back float because balance is equal to balance minus amount, and then I want to return back the balance itself, whatever the current balance is now how do I handle it? There is a problem. So this return value represents what? Does it represent the balance on hand, or it was a failure -1? Then I will have to have all that kind of if else and if over here, that if the value is greater than 0, then it was a success. Else if it is equal to, yeah, if it is less than 0, that means if it is -1, it failed. And if it was greater than 0, then that is the value of the current balance now after withdrawal. I mean, it used to be it used to be very difficult and cumbersome for us to manage exceptional flows. Note my words. Exceptional flows. What do you mean by exceptional flow in your program? Your program has got some logic to execute based on some condition, right? You have an exceptional flow. That means not the basic flow, but the exceptional flow. One is the happy path. You insert the ATM card in your bank, you go to the ATM, you go to your ATM in order to withdraw money. You insert the card, it asks for the PIN number, you enter the PIN number, it asks for the amount, you enter the amount, and it withdraws, and it dispenses the cash, it ejects the card. Happy flow. Now see the same use case. It asks, you insert the card, it asks for the PIN number, you enter the PIN number, it asks for the amount, you enter the amount. It says the amount entered by you is more than the balance on hand. Exceptional flow. You have a detour now. You have a detour, right? This is not the happy path, but an exceptional flow. So in order to handle such exceptional flows, which can be an error, it can be a validation error, it can be any kind of a business error, or maybe a technical error, you need to report back to the client class that had invoked the method, that is invoking the method rather. You need to tell the client class that there was a problem. There is some or the other problem in the method that you have invoked, some validation failure, or maybe some other kind of a failure. How do you do that? You can very well do that with the return codes like -1 and stuff, but that's not the elegant way of handling it. So I will still keep this as float. What does that mean? If it is successful, it will return to me the current balance on hand. But if it is not successful, if the validation has failed, then I do not want to return -1 or something to tell my account app that something went wrong. Instead, I would like to throw an exception. I would like to throw an exception. So I will create a class, okay, which will be an exception class. I'll say insufficient balance exception. And any class that you want to, treat that class as an exception. If you want to treat a class as an exception, so that you create an object of that class and throw. Throw is the keyword that you use in order to throw an exception. Then in that case, such a class must extend from exception. It must extend from exception. We will come to the details of whether it must extend from exception or throwable. We will come to that in a moment. But then otherwise, this is how. You can also override the constructor. You can very well write insufficient balance exception. This is my constructor, right? So this is the default constructor. You can also have insufficient balance exception. I'm overloading the constructor with a message. I'll say string message. What is the message? What is the message that you want to pass? Correct. So I'll say super in brackets. I will have to, of course, invoke the method, the super method. So I'll say super, and I'll say whatever the message is, that is the message. So exception is the class. Exception is the class. See this, which extends from throwable. Throwable is the supermost class in the exception hierarchy. Here, please see there is something called detailed message. You can see this detailed message here. It is this detailed message in which that message value will be stored, right? The one that I'm passing as a parameter from here, insufficient balance exception. So whatever is the message that will be passed to the constructor of this class, that message will be stored in a variable called detailed message. And what I can do now, I can go to my account class, and if greater than equal to amount, then everything is cool. I return my balance, or else I throw new insufficient balance exception saying the balance on hand is insufficient. Okay, insufficient. Okay, and I would like to tell the user what the balance is, or the client class. So I'll say this dot balance. Correct? This is what I want to do. Now, if you say that I want to throw an exception like this, you must include a throws clause here so that insufficient balance exception. Why this is made mandatory by Java. If you are throwing an exception, you must have a throws clause in the signature of the method, not my words, in the signature of the method. This entire line is the signature of the method. Which value you are returning back, whether it's a void or you are returning back a value of some data type, what is the name of the function, what are the parameters, which exception you are throwing, if at all you are throwing an exception, this entire thing, this entire line is the signature of the method. So in the signature of the method, you must do this. Why? Otherwise, within the code, whatever you have written, how will your client class know about it? How will your client class know that it is supposed to surround it in a try-catch block if you do not put it in the signature of the method? If you don't put it over here, how will it know? So now since you have done this, see the way I'm going to write this code is like this. I'll say account dot withdraw and I'll say 5001. Okay, I'll say 5001. I will surround this in a try catch block. I'll say try. I'll close the bracket here. I'll say catch. And which exception do you think I will be catching? Insufficient balance exception. I'll give a name to that variable ex. See, this is the cleaner way instead of writing if else and if. And here I will write s out. I will say, I will just print the message ex.get message. Which message will be printed? The one that was passed as a parameter at the time of creating a new object of insufficient balance exception. So this constructor gets executed. From this constructor, you set the value in the detailed message. So here you go. Now you see this is going to get printed. You see the balance on hand is insufficient and the balance is whatever the current balance is, 5,000 is shown here. But if at all, I give something like 4,500, which is just cool, I just return back here. Okay. I mean, I just execute and nothing happens. Why? Because I mean, everything happens. Not that it doesn't execute, but it's just that I'm not printing anything. So what I'm going to do is I'll say float current balance is equal to, and then here I'll write s out. The current balance is, okay, I'll say withdraw was successful. And the current balance is, I'll say plus, and I'll say current balance, right? Take a look now. See this, withdraw was successful. The current balance is 500 because you have 5,000, you had 5,000 and now you have 4,000, you have 4,500. So very simple, so very simple. If I again make this as 5,002, current balance will remain as it is because withdraw is going to fail. And you see this, you're getting insufficient balance exception. You say the current balance on hand is 5,000, which is insufficient for you to withdraw 5,002 rupees. See the elegant way of handling it. This is called exception handling. I repeat, this is called exception handling. Correct? So you must, and there are different types of exceptions and stuff. I'm going to explain that in detail for sure. For now, I am committing the code. Please take a look at it. Play with it. If you want to make some changes to it, please feel free to make changes to this code, but then copy paste this code in your own project and then make changes to it. Okay. And explore this code. Exception handling. There is a test. There is a test. Okay. So I'm giving you all hints, right? So you must be very comfortable with the basics of exception handling. We have not yet finished with this topic of exception handling. I will explain quite a few, things beyond this. So, but first explore this. I will give you 10 minutes. It's simple stuff, but feel free to ask questions. If you have any questions, absolutely feel free. Okay, let me know if you have any questions. Come on, let's get started. I have already pushed the code. Okay, come on. So let's continue. Now you see this, I did extend this from exception. But exception is not the class which is the last class in the exception hierarchy. Actually, in the hierarchy, the supermost class is throwable. As you can see this, throwable implements serializable, but it does not extend from anything. No, it does not extend from anything. So right on the top, you see this, exceptions, okay? Right on the top, you have a class, and that class is, what class is that? That class is throwable, okay? Throwable is the class. Let me give 15 out here. Okay, so this is throwable, isn't it? And I will remove that stereotype stuff. I'll remove this as well. This is throwable class, right? And then you have class like this. There are two classes. One is exception and the other, sorry, the other is error. These are the two classes that inherit from throwable. Both of these, they inherit from throwable. So you see this, I will again use UML and I will use generalization. Here it is, right? Generalization. So, sorry. Oops, that's bad. Yeah. So this extends from this, right? Okay, right? It extends. And then similarly, error also extends from this error also extends from the same throwable class. But then what is the difference between the two? Error is usually used for fatal errors which cannot be recovered from. Like for example, out of memory error, it's an error, right? And there are many other, stuff like, well, it's not, immediately popping up in my mind, but then there are many errors, many classes that extends from throwable, but it is an error and usually used by the JDK library itself, the Java library itself. We do not create classes extending from error. We always create our classes that extend from exception. So if you have any business exception or any kind of an exception to create for your own application, then in that case, you better create an exception which extends from whatever your exception is, Okay, I'm using this simple arrow now. That's easier for me to draw. Any exception that you want to create, it can be extended from exception. Like the way we have done, we have created insufficient balance exception extending from exception, right? But then you can have any exception inherited from exception, but then there is yet another special kind of an exception called runtime exception, which is again out of the box available by Java. It's out of the box available in Java. Runtime exception, see this. Okay, so you have runtime exception. Your runtime exception also extends from exception, but there is a specific thing about it. What is that specific thing? This is an unchecked exception. I repeat, runtime exception, it's an unchecked exception. Unchecked exception. What does this mean? It means that it can go without a try-catch block. See, using a try-catch block is checking for an exception, isn't it, friends? Come on. What do you mean by try-catch block here? You were checking for that exception. So let me go back to the same source code, account app, and you see this here. You see this here. Using a try-catch block is what? Checking whether the exception is going to occur or not. If the exception doesn't occur, everything goes smooth. You proceed further, or else it drops your control immediately to the catch block. So if at all withdraw throws an exception, it comes into the catch block. Will it execute this? No, it will directly jump here. That's what try catch block is. So you are checking for an exception. Why? Because withdraw extends from exception. I mean, it throws an insufficient balance exception, and it extends from exception, which is a checked exception. So you see this, I will, you know, put this as exception is a checked exception. So this is a checked exception, no doubt about it. This is a checked exception. Now, one important point about checked exception is this, that all the exceptions that are inherited from exception class directly are all checked exceptions. But this special exception, runtime exception, you see, I have not created runtime exception. It is inherently available in Java. You can see that java.lang.runtime exception. It's there since JDK 1.0, written by Frankie Allen. So you see, this is an unchecked exception, and you can, any kind of an exception, any exception, my runtime exception, okay, or any kind of an exception, whatever is the name of the exception that you want to create, and whatever is the type of exception, for any purpose you create an exception, if that is inherited from unchecked, then all the exceptions that are inherited from unchecked are also unchecked exceptions. So in this hierarchy, all exceptions are checked, and in this hierarchy all exceptions are unchecked. Right? That's how it is. What do you mean by unchecked exception? As I said, that if an exception is a checked, which is exception is a checked exception, you must and must surround it in a try catch block. You must and must. But now see the statement that I'm making. If at all I make this insufficient balance exception as a runtime exception, now it can go unchecked. It doesn't mean that if you check it, it will give you any problem. It will give you any compilation error. No, it will not throw any. It will not give you any compilation even if you check it. But if you don't check, no worries. It will not. Compilation will at least succeed. It does not mean that during runtime it will not pop up. If at all it has to pop up. For example, you are passing 5002, which will result into throwing of an exception like insufficient balance exception. But since this exception is a runtime exception, it did not force you, note my words, it did not force you to surround this in a try catch block. But it doesn't mean that it will not come up. If at all the condition is not fulfilled, and if at all withdraw function, if it uh, if it really ends up throwing an exception like this based on the condition, then in that case the runtime exception aa jayega. That runtime the exception will be there. See this. So runtime I get that exception. You can see that the balance on hand is insufficient. So it is the JVM that has received finally this exception in that thread, and it has shown that exception. It has thrown that exception, and it is showing it here on the console. Right? That's how it is. So such kind of exceptions, the one that we have taken as an example, shouldn't be runtime exception as such. But then many a times, you do not anticipate that something will go wrong. Here, definitely, things can go wrong. Really, it's quite possible that you are trying to, 3 out of 10 times it may so happen that someone is trying to withdraw money, which is more than the balance available. Correct. So in that case, it must be a checked exception. But then many a times, you do things which are uh, okay. Yeah. Why is this giving me an error? Because now it is a checked exception. I must surround this in the try catch block, or else see, it gives me an error. So I will go here and got this. See, now everything works. Why? Because it is a checked exception, and I must surround this in a try catch block. But there are many. Say, for example, why would you, if you wanted to convert a string to an integer, I've got a string and I say value is equal to, in double quotes, 25, in double quotes 25, but whatever the value is, I want to convert it into an integer. So I'll say int, okay, int value is equal to integer dot parse int, and I pass that string as a parameter. Okay, or else let me change this to string value. See the name of the variable. I'm changing the name of the variable to string value. So I'm passing. Now, what does this mean? It will do parsing. It will parse string into an integer. I repeat, it will parse a string into an integer. So this will succeed because 25 can indeed be, parsed into an integer. So I just put the value, int value. And now when I run this, I will get the value 25. See, I'm getting the value 25, but intentionally, unintentionally, if I do something like this, 25a. Now, can this be passed into an int? This cannot be passed into an int. There is a character out there, right? So in such a case, now when I run this code, you see this, it's going to throw a runtime exception called number format exception. See, java.lang.number format exception. Did it force me to try catch, put this parse int in a try catch block? Did it force me? It did not. And I click over here, you see this number format exception it extends from illegal argument exception, and illegal argument exception is in the hierarchy of runtime exception. So it need not be caught. See, note my words. I'm saying it need not be caught. I'm not saying it must not be caught. I can still have try here. If I want to do defensive programming, I can still have try here, and then I say whatever, number format exception, yes, EX, and then here I'll write as out. So what does this mean? I am gracefully handling the error, right? I mean exception. I rather use the word exception, and then I say string value. Okay, I'll say string value could not be converted to int. See, now okay, of course I've got to take this over here now, right? So now see this, it works. It tells me, see, 25a could not be converted into int, but if suppose it was really a digit, really a number, it will successfully convert it into an integer, and I get the value 25 here, see, as a result of this system.out.println. So friends, you've got to remember this. Okay, all the diagrams that I have created up till now, I have already shared with RPS, and you will soon get it, right? But all the diagrams that I'm creating from now onwards, today onwards, this is, I will share this tomorrow, right? So you see this is the supermost class throwable exception error, any exception, runtime exception, and my runtime, or any other. I'm saying my runtime, it can be any other, exception. Anything that is in the hierarchy of runtime exception are unchecked exceptions. That means they can go unchecked. Any doubts, any questions? Any doubts, any questions? This is cool, right? This is clear. Very good, great, superb. Now, friends, something important and interesting. Wait a minute. Okay, you all can all see my screen, friends. Can you all see my screen? Okay, so this is your attendance. Cool, this is your attendance. Now, let's figure out a way in which so I don't want to take the roll call here because this is something that I need to submit to them. So I don't want to take the roll call like, Abhijit, Akula, Anand for, June 15 and 15 and 16. We are on 16. We are on the third day. You tell me who was absent on June 14. I will wait for 30 seconds. Who was absent on June 14th? I will mark him as absent. Come on, you've got to be honest, huh? Of course, needless to say. I'm sure you will be honest. Right, so I'll say P for present, right? And oh wow. And also you must tell me if your name is missing here. You must tell me if your name is missing. See, these are the names, my dear friends. These are the names. If your name is missing, please tell me. So make sure that your name is there. So who was, sir, can we rename our names? Rename your names. Okay, yeah, yeah, sure. Tell me, Likita, what name you want me to put for you, Likita? Where it is, Likita Nagraj, yeah. What name do you want me to put here? It's Ashish, not Ashish. Okay, sorry about that. Ashish. This is okay, Ashish? Likita VN. Okay, so this is the name you want me to put, isn't it? Likita VN. Okay. This is okay, Likita? Abhijit Sherige. Abhijit. Abhijit. Okay. It's JIT. Abhijit. Okay, Abhijit. But then Abhijit, your name here is JEET, right? So you want me to put Abhijit. ठीक है, चलो डाल दिया वो. अनिकेंदु चौधरी, not चौधरी. आपने जो डाला है वो ठीक है चलो. ए, चौधरी. Okay, sorry. This is okay? Anikendu? Okay, perfect. Right? So your names are here, isn't it? So anyone who was absent on June 14th? None of you all, right? What up? Hello? Yes? Ah, Devdeep. Yes. Your name is not here? Here it is, Devdeep. Mm-hmm. Okay. So this is the way. So they understand. This is just the plain attendance. JEE. Okay. ये ठीक है? This is okay? Yeah? Perfect. Yeah, yeah, yeah. Right. Let me know if any one of you want me to make any other corrections here. So tell me, June 15, who was absent on June 15? I think one of you all did tell me that you were absent. Okay. Anand Thakur. Okay. Yeah. Anyone else was absent? Anand Thakur. Okay. What about today? So you're so you are all present. Okay. So if your name is here, right? So you're here, right? So Abhijit, Akula, Anand, Ananya. So I'll just call out. So okay, now for today at least you will have to say yes to me. So you type out yes over here immediately the moment I okay. Akula, yes. Okay. Abhijit, Akula, Anand Thakur, Abhijit. Just say why. Why should also be good. Anand Thakur, yes. Ananya. Anikendu, every one of you. Just put yes, I will cross check. Yeah, present sir. That's nice. Okay. Yeah, so I believe every one of you are there. Correct. Good, cool. Okay, good. Right, so we are going to do the same thing. Okay, right, so I'm going to pass this over to them. I better send them the Excel as well. Okay, all right. So, any doubts, any questions on this, friends? Anything? Or else I'll give you a time to practice on all that we have done today. I'm not picking up any new topic, and we will continue with the design patterns from tomorrow onwards. Again, it's going to be all Java, but we will be writing a lot of classes, and we will learn what it means by design patterns, what it really means by design principles, design patterns, and stuff, and then we will move ahead accordingly. Right, friends? Right, all set for tomorrow. Right. So it's what's the time now? Okay, it's 5:33 anyways. So do the research work, do all the learning work till 6 o'clock. I am connected here. I am around. If you have any questions, I will keep on looking at the chat window. And any questions you have, I will certainly answer your questions. Right, friends? What is parse? Okay, good. Parsing is again, you know what? It's a beautiful question. Why I say beautiful question. You know what? When you say what is parse, if I were in your place, what would I do? Tell me, what would I do? What did I do? I will open up what? Correct. So first I'll try to get the literal meaning of that English word, parse, and half the war will be won there and there itself. Resolve a sentence into components, parts, and describe their syntactic roles. Right? Computing analysis a string or a text into a logical syntactic component. Correct? An act of parsing a string or a text. A failed parse was retired. So parsing is converting, parsing, going through it and parsing it. Now this is a plain simple English word, that is used in order to convert one data type to the other. So if you have an integer and if you want to convert, if you have a string and if you wanted to convert to an integer, so integer provides you with something called parse int. So you provide a string to it, it will parse that string into an integer value conversion. Right? You got that? No, not Google. Google is also correct. TK. Dictionary. Yes, dictionary. Oh, yes. You want me to push the code. Right, friends. So the code is pushed. Okay. अरे राकेश चला गया. Where are you? Rakesh, you left. He left. Okay, no problem. But he knows quite a few things, so it's okay. Rest of your friends, please do some research work. Is better or Eclipse? It's a personal choice, like it all depends. But let me tell you, all the top guys in the industry, you will find them using IntelliJ. So if you want to separate boys from men, you will find men using IntelliJ. I'm sorry, that's how I like to put it. But then IntelliJ is very advanced. Well, beautiful. Continue with Eclipse. It's okay. No problem at all. I mean, you can do wonders. There is nothing that I mean, it's not that you will have any kind of drawback while working with Eclipse. It's just that IntelliJ, and you know why IntelliJ? It's actually, you do have a community edition, but if you want all the features, then it's a paid. They charge us for a single user. They charge me $8.9 plus taxes, so it comes to somewhere around 1,400 rupees per month. But the kind of, especially for front end development, the kind of features it offers is just next to, I mean, it is second to none. It's awesome. So we are quite used to it, and we use IntelliJ. All right. But your choice. You can use Eclipse, NetBeans, whatever suits you. Java still remains Java. But Eclipse is not good for front-end development. So I have got to use Visual Code for front-end. We used to do that. We used to use Visual Studio for, Visual Code for front-end development and for Java Eclipse. Then we started using IntelliJ, wherein we now have front-end development as well as Java development here using the same IDE. So what is the shortcut for commenting the code? Command and backslash, see. So if I select this, you see, I'm using command. Now, you see, Hannah, how do I show you? So I'm pressing command and a front slash, not a backslash, a front slash. It will comment it. And the same for uncommenting as well, right? For the same for uncommenting as well. It toggles between comment and uncomment, right? Yeah. So it will give you double slashes, double slash. Right? Good, good, good. Any questions, any doubts? Absolutely.